if you think about what the word extreme means, okay, not extreme sports and extreme all that, although that has the same meaning as extreme. They're called extreme sports because they're out there, right? They're pushing the edge. They're on the edge of things. Okay? I know you're all excited, but it's better if one of us talks at once, right? If you talk about extreme values, you're talking about values that are out there, right? On the extremes. If you talk about going to extremes, you're going to kind of the edge of what you're capable of doing. If you have a function that looks something like this, sure, draw that. Or something like it.
I don't want to draw that.
Actually, okay, then draw this.
Does it matter what we draw?
I'm thinking maybe we want both the ends going the same direction. Doesn't matter if it's up or down. You could tailor your diagram, the words we put on it here, to suit.
What if I use three-dimensional plane board?
You do what you like. You have a line that has three ends on it, then sure. There are some extreme values here. When we talk about the value of a function, we're talking about the y values. When you say what value does this function have? Value of a function refers to y values, right? Not the x values. You looked at quadratics in grade 11 and you talked about whether they had a minimum or a maximum value. A graph that opens upward has a minimum value right here because that's the lowest it goes. Whatever value that is, on the y-axis, if this is 3, it has a minimum of 3. It has an absolute minimum of 3. That is the lowest the thing ever goes. It never goes lower than that. If this was a cubic, but it turned around like this and went back down, is this the absolute minimum that ever goes? Not anymore, right? If it goes on that side. Then you wouldn't say it's an absolute minimum. You would say it's a relative minimum. It's a relative minimum because near that point, right? Nearby here, it's the lowest it ever goes. If you're near to this particular x value, it's the lowest. It's a minimum locally, right? So you can call it a local minimum. But it's not an absolute minimum of the entire function. It's not a global minimum. Global meaning the whole thing. Okay, so you can call this global or absolute. Absolute and relative, global and local. For what I drew here, this minimum point right here is the absolute minimum. Whereas this point over here is a relative minimum. And then what would this be right here? Relative max. Just like anything, right? If you say, if you're nearby to some mountain, like what's the highest mountain around here? Probably Mount Baker's the highest mountain close to us. And but that's not globally the highest point on the earth, right? I mean, Mount Everest is the highest absolute point. Relatively speaking to what's around it, Mount Baker is a maximum point, right? It's pretty tall, yeah. It's very tall. Is it tall? You didn't see that it was tall when you were looking at it? On a clear day, look, it's pretty clear there. I better not talk about local mountains and stuff, though, because I'm identifying where we are here. Identifying where we are.
We're at Mount Everest right now.
We're at Mount Everest, talking about absolute maximums. What about this function here? What does it have? I think someone can figure it out by going to my website, which says what school we're from. So, what does this have as a maximum here? Okay. Does this thing have a maximum? Does this have a maximum? Well, yeah, you could say the maximum is infinity, but since that's not a finite number, which is why they call it infinity, it's not a absolute number that you can. It's infinity. Yeah. Let's call it infinity. Exploring extreme values. If you remember this kind of notation for intervals, open and closed, like infinity to negative infinity means all real numbers, basically, right? The square brackets 0 to 2 means, as a number line, it means from 0, solid dot on 0, up to 2, right? It means over that interval, draw the thing. It's a parabola. I'm pretty sure you know what it looks like, right? Over all real numbers, it looks like this, sort of. Over the interval 0 to 2, it's got a solid dot there, and it's got a solid dot there. At 2, this is 4, and this is 0. Does it have an absolute extreme value on that domain? Does the first case here? The first case has an absolute minimum of 0 at x equals 0. There's no absolute maximum. If you restrict the domain to just this between 0 and 2, now it has an absolute minimum and absolute maximum. Okay? Okay, you can write that out. Absolute minimum of 0 and absolute maximum of 4, right? At x equals 2. Okay, if you restrict the domain, then it has a maximum. Remember that the curved brackets means an open interval. You talk about an open interval, it means it's got a hollow point on the end. Right, as a number line, this looks like open circle at 0 and filled in circle at 2, which will require a little bit more thinking. So we have an open circle there, and it goes up to there. How does that make it different? Now there's no minimum, right? There's no minimum because, well, can you say what the lowest value that function has is? It's not 0, right? It's getting close to 0. You can get arbitrarily close to 0. But it doesn't have a minimum value when it's an open interval, when it's an open point like that. It has an absolute maximum of 4, but no absolute minimum, or no minimum at all, right? If you took any other interval in there, you could say it has a minimum of whatever it is, right? Between 1 and 2, it has a minimum. But for the way this is, between open interval on that, if there's an open interval on both ends like this, then it doesn't have, there's no extreme values at all, right? No extreme values. No max or min. This is all stuff I think you understand here. Determine the maximum value and minimum value of that. This cosine function. Cosine between negative pi over 2 and pi over 2 looks like this, sort of, again. And sine looks like this. We don't want to belabor the point here, but this has, I'm not going to write out everything here, but this has a maximum of, what's the maximum of cosine and sine for that matter? Is 1, right? Maximum of 1. Does it have a minimum? Well, it happens in 2 places. Does that matter? If you say, what's the lowest this goes? 0, right? Has a minimum of 0. Even though that happens twice, it has a minimum, right? It's the same value. You don't care about it where it actually happens. You just care what's the lowest it ever goes here, right? The lowest it goes. If this is a Ferris wheel, you're going around on a Ferris wheel. Okay, repeatedly, you go up and you go down like this, and you go around. That's going to give you the car's coming off the track here, and it's not really circular, but you're hitting the minimum point many times, but it's still the minimum value. Like, what's the lowest you ever go is whatever that height is. What's the highest you go here? Even if it happens more than once, right? Incidentally, when you have a point rotating around like that, it does look like a trig function. If you draw on the graph, I am going to stop this now because we're going to hit the end.